Okay, for this video, I'll be going through separation techniques. So basically, you must find a difference in the properties of the constituents that make up the mixture to be able to separate them. So for this chapter, we are actually separating mixtures which is not chemically combined, right? So the first one is separation by magnetic attraction. So we use magnet to separate magnetic from non-magnetic material. So in our syllabus is iron, steel, cobalt, nickel. Okay, one of the common mistake is choosing, thinking that copper is a magnetic material, but it's actually cobalt. Okay, so take note that not all metals are magnetic materials. Example like your gold and copper and silver. Now, magnetic separation is used in mining industry. Basically, is to separate the iron from the non-magnetic material, and also in junkyards where they separate the steel, which we can be reused from the scrap metal. The next method is separation by filtration. So you must be able to draw this diagram, okay, and to label it. So basically, it works by separating insoluble. This is the concept: insoluble solids from a liquid in a solid liquid suspension. So the thing that's captured in the filter paper is the residue. It is insoluble solid, so it's being trapped in the filter. Then whatever comes out will be the filtrate, which is the fluid or the liquid, because it's able to pass through the filter. Now, filtration is used in water treatment plants where the raw water is filtered by sand filter to remove solid particles and obtain clear water. Okay, the next one is separation by evaporation. Why do we use this? It is to separate the dissolved solid. So this is different from the filtration because in this case the solid are actually soluble. So the solutes are actually soluble. So it is dissolved in the liquid or what we call a solvent. So the first one is boiling to dryness. Okay, so it's used when the solute left behind is not easily decomposed under high temperature. So example is your salt. The other one is evaporation using steam bath or water bath. So it's used when the solute is unstable and decomposes easily at high temperature. So example your sugar. So you may want to read the question carefully. Okay, but we can also use a water bath for salt as well. So maybe it is good that you memorize how to draw these two diagrams. Okay, next is separation by simple distillation. Okay, so basically there are two processes here, the boiling and the condensation. So is to separate the solvent from a solution. In this case, now we want the liquid. Okay, so it can also separate solutions of two liquids, okay, based on their different boiling point. So this is the key concept here. Okay, they may not ask you to draw this, but they will ask you to label. So this one is your distilling flask and the boiling stones. So the boiling stones are used for smooth boiling. Okay, then we have thermometer. Then take note that this is the condenser. We have cold tap water going in and the warm water will come out because it's in contact with the hot vapor. And what we collect here is the distillate. Okay, so you also need to know the function of the thermometer because we want to maybe get a certain liquid out, and this liquid has a fixed boiling point. The pure liquid has a fixed boiling point. So the thermometer will be able to tell us the temperature at which the vapor is produced, right? So because it is heated up, the liquid that has a lower boiling point will actually form the vapor first. So if we see that example, if we want to get alcohol, which is at a boiling point of 78 degrees, and once the thermometer register a reading of 78 degrees and is stable, we know that the vapor that's coming out is alcohol vapor, and the distillate after it has undergone condensation will be the pure alcohol. So simple distillation is used to obtain water from salt solution and water desalination. So you may want to memorize this. Okay, so another one is separation by fractional distillation. This is actually not in our syllabus, but maybe it's good to know. Sooner or later you will have to learn this in upper sec. Now is to separate miscible. Miscible means they can be mixed together. Okay, they mix up together. So what is the opposite of miscible? It is immiscible. Okay, so an example will be oil and water, right? If you add oil and water together, okay, they will actually separate because oil is actually less dense and it doesn't dissolve in the water. So we can actually separate miscible liquids with different boiling points because we don't know whether the one floating on top or the one that is below is which liquid. Okay, they all have been mixed together, right? So we actually use fractional distillation. So this is slightly more difficult than the simple distillation. We have this fractionating column. Okay, so we can just read this for knowledge lah. Okay, so fractional distillation is used to separate crude oil into petrol, kerosene, and diesel. Okay. Okay, this is important. Separation by vapor chromatography. So to separate and identify the different colored components in the mixture. Take note, the component which are more soluble will travel further on the chromatography paper. And therefore, the different colored components, if they have three, if it's made out of three, then I should expect 3 dots on the chromatogram. Okay, they will be at different locations because they travel at different rates, different speed. So these are the application for chromatography we use to detect urine in detect drugs in urine sample. Okay, then there's one more is separation by using separating funnel, but also not in the syllabus, is to separate immiscible. That means they do not mix. Okay, they do not mix or blend together. So example, your oil and water. Okay, so as you know, the oil will have a lower density and it floats. So I can actually have a tap here or stopcock to drain out the water. And once I see that all the water has been drained, then what is left will be the kerosene oil. Okay. So this reverse osmosis is also not in our syllabus, but you can just read it for your knowledge.